Hey everyone, we're starting off our geometry course with a lot of vocabulary as we have to define what we mean by point, line, plane, segment, ray, all of that. We have very specific descriptions that we're talking about, very specific figures and how to diagram them. The notation that we use is the symbols. We have very specific ways of doing this, and so it's so important to be able to learn this right off the bat. You want to think of geometry as its own language. You need to be able to communicate using the symbols and the notation because there are right ways and there's wrong ways of doing it. And if you do it the wrong way, then you're not communicating it correctly or accurately. So we're going to go over these definitions, and our goal is to also be able to read diagrams and even draw some diagrams ourselves. So let's start off with this very first term that you see here. We're talking about a point, the most simple of objects. So a point is a specific location. It has no dimension and is represented by a dot. So you know what that looks like. There's your dot. But we have to label every dot. So you always put a capital letter. No lowercase letters are allowed. It must be a capital letter next to the dot. We're not calling the dot A necessarily. We're calling the location A. So a point is a specific location. We're saying it's at that spot that we have a unique feature. We communicate this by describing it as point A. And there's our symbol for that. Now, this has no dimension, and that might seem a little bit strange, the idea of having no dimension, because you could take a ruler here and say, well, if I were to measure it, it looks like it might be 2 millimeters, 3 millimeters. But that's just a physical representation of the concept. The concept is that it's a location, not a size. And so we're saying the location has that name. So think of something really, really small that has no dimension. Well, how about something really small like a TV pixel? Yeah, you might be able to measure that too, but I'm trying to think of something so small that you really can't see it with your own eye. So a TV pixel is what I'm using here as an example. Now, if we were to take several of those locations, those points, and connect them together, we could create a line. So a line is a connected straight path. It has no thickness, and it continues forever in both directions. So that means we're going to put arrows on the end of this line to indicate that it continues forever in both directions. Now, there are several ways that we can notate this, and so we need some letters on this diagram to make sense. Let's put 2 points on that. We'll call it point A and point B. And so I can call this line AB, and we put that little miniature line symbol with arrows on both ends right above the letters to communicate that this symbol is telling us we have a line. Now, because the line goes forever in both directions, it doesn't really matter which letter comes first or which comes second, so we could also call it line BA. We can also add on to the line, at one of the arrows, a lowercase italicized letter. Usually L or M or N is used, so here's my lowercase italicized letter. We can also call this line M. So, line M is how we would use it. Now it has to be lowercase, so notice the difference between when we use uppercase and when we use lowercase. This might not be the best example, but if you think of train tracks and you think of one of those, now of course train tracks can curve around a bend, but in a straightaway it looks like they just kind of go on forever. So there they are, 2 train tracks running parallel to each other, representing the concept of a line extending forever in both directions. So a plane now has 2 dimensions, and it is represented by a shape that looks like a floor or a wall, but it extends without end. Through any 3 points not on the same line, there's exactly one plane. You can use 3 points that are not all on the same line to name a plane. So let's break that down. First of all, we could draw 2 different ways. Here's a horizontal plane, and here's a vertical plane. So it's a shape that looks like a floor or a wall. So if we want to draw a horizontal plane, we'll make it look like a floor, and if we want to draw a vertical plane, we'll make it look like a wall. To draw a horizontal plane, we're going to create two horizontal segments that are slightly offset from each other, and then we'll connect the left and right ends like so. So a horizontal plane has these horizontal segments on the top and the bottom. A vertical plane then will have vertical segments on the left and the right side. So here's a vertical segment on the left, here's a vertical segment on the right. Again, slightly offset them, and then we'll connect the top and the bottom. So this should look more like a wall, and the horizontal plane will look more like a floor. Now again, we need some letters inside the shape to be able to name it. So, through any 3 points not on the same line, there's exactly one plane. So we need 3 points not on the same line. So we're going to scatter them around. So here's 1 point, here's a second, here's a third. Now if it's a point, it has to have a letter. So give it a capital letter next to each location. So there's point A, point B, and point C. So when we want to name the plane, we're going to use 3 letters not on the same line. So we could call this plane ABC. Now you heard me say the word plane in front of the 3 letters, but I didn't actually write down the word plane. Here we're writing down the word point in front of A to communicate we have a point. Here we have 3 letters, but I'm not writing down the word plane because when you see 3 letters, you interpret that symbol to mean a plane. Now it doesn't matter the order of the letters. You could call plane ACB, or you could call it plane BAC. And you can keep shuffling them around. Plane BCA, plane CAB, plane CBA. All of those names communicate that this is the plane we are talking about. Now there's also another way to communicate the name of this plane, and that is by looking at the name of the letter that is in one of its corners. Now we haven't put that in there yet. We're going to do that now. We're using a capital letter, and I'll use letter Q. I'll put that right there in the corner, and notice there's no dot next to it. So if there's a dot next to the capital letter, it's a point, but if there's not a dot next to the capital letter and letters in the corner, it's the name of a plane. So we would call this plane Q. So you can see I am writing down the word plane in front of the single letter so that we know we're not talking about a point, we're talking about a plane. So here's another example. Our vertical plane, put 3 points. Now again, they cannot be in a straight line. Call this DEF. So point D, point E, point F. So this would be plane DEF, or plane DFE, etc. The pattern continues. You can shuffle those letters around any way you want. Let's put a capital letter in one of the corners here. Let's put a capital N. Notice there's no dot. It's not a point. This is plane N. So we can call it plane N. And the example was pretty much used right here in the description. You can think of a floor or a wall. The idea, though, is that the floor would extend in all directions without end. In the next section down below, we're taking a look at segments and rings. So let's take a look at some of these. We can call this 2 ways. We can call it a line segment or just a segment. So a line segment is a portion of a line consisting of 2 points and all the points between them. So we're going to take that line that we drew earlier and chop off the ends. We just want 2 points and everything between them. So here is my line. There's a point. There's a point. I labeled them A and B. And even though we don't draw dots on the line, the idea is that there's an infinite number of dots between A and B. And so these are representing points A and B on the ends, and all points between them. So there's lots and lots of points there. We just don't label every single point. These points on the ends are called endpoints. Alright, so the endpoints are then what we use in naming this segment. So this is called segment AB. So we put a little dash above the letter A and B. Again, we don't use arrows because arrows would communicate that it was a line. And again, we can go forwards or backwards. So we could call this line BA. Think of an example like a ruler. If you have a 6-inch ruler or a 12-inch ruler, well, there's a clear starting point and there's a clear ending point. So this might be your 0 and this might be your 12 inches, and there's your ruler edge. A ray is going to be a portion of a line. So we're taking this line that we saw earlier up, and again we're just taking a look at a portion of it. It is a portion of a line that starts at a point and continues forever in one direction. Alright, so we're going to borrow this line here, and this time we're going to chop off just one of the arrows. I'm going to leave the other arrow on. So let's take a look at this ray. I drew point A as the end point of this ray, and point B is the point that the ray is passing through. So we were labeling the endpoints previously, so the ray has one endpoint. With the lines and the segments, we could name them forwards or backwards. Not so here. The endpoint must come first, and then the point that the ray passing through is listed second. So we call this ray AB, and the end point is always first in the name. As an example, if I were to create a different ray, let's say I'm going to create another ray, and I'll just use this little space here to fit it in, and I'll use an endpoint called D, and the ray is passing through point E. Now, even though this ray is drawn on the diagram as if it were passing sort of upwards and pointing upwards, doesn't matter. The symbol always extends to the right because we read our letters from left to right. The first letter is the end point, which is D, and then the second letter is the point that the ray passes through. I like to think of the sunshine, so there's your sun, and all the rays of the sun extend forever. They start at one location and they extend forever until they hit an object and create some shade. But think of the rays of the sun. Now we can create shapes by combining two rays, and we're going to point these rays in opposite directions. So the opposite rays are two rays that share the same endpoint, but together they create a line. Let's see this happen. This does help if you have a pair of different colors, so we can see the two different rays and where they go. So I'm going to take this ray that we drew earlier, recreate it. So here's ray AB. That's one ray, but we want a pair of rays, and this second ray should share the same endpoint, but they should point in opposite directions. So if you take your second color, here I'm going to have again my endpoint at A, point in the opposite direction. I must put a point on here called C. So this is ray AC. So the way to think about this is ray AB, so again the endpoint A is always listed first, and ray AC are opposite rays. Now you realize that when we take two rays and put them together so that they have the common endpoint, it really just creates a line. And so in our basic diagram of a line, we have to have a minimum of 2 points. Here we just happen to have a third point, but it does create the line. Now in the same way, you can take this line and pull it apart and create those two rays. Let me do a quick demonstration. So here's ray EB, here's ray EH, Alright, so if I were to line them up so that E is at the same location, there is my line. Okay, so if you have any line, you can cut it and essentially create two rays. So you could take two rays to make a line, take a line, pull them apart, and find two rays pointing in opposite directions. You can kind of think of the XY coordinate system as a way of showing how those opposite rays are formed, because on the x-axis you have a line, but then you have this y-axis that passes through, and which is another line, but they create this point of intersection right here. So you can think of this as one ray pointing to the right and one ray pointing to the left. One ray pointing up, one ray pointing down. So those are your opposite rays, but they also form a line. We've already talked about endpoints. We've diagrammed them up here. An endpoint is a point at either end of a line or the starting point of a ray. And so I'll just say see above, since we already talked about those. Now we want to take a look at what we call collinear points and coplanar points. And so collinear points are points that lie on the same line. We've already seen an example of that here with our ray. Here we have some collinear points. They're points that are together. That's what co means. Collinear means together on the same line. So I'm drawing a very similar diagram. There's my line. I'm going to put a bunch of points on here. Point A, B, C, D. Those are my collinear points. And then for contrast, I'm going to put one point not on the line, point E. Alright, so I would say points capital A, capital B, capital C, and D are collinear. As an example, you can think of a number line. Right, so you think of a number line. It is a line that goes forever in both directions. You put arrows on the ends, and we have a variety of points that go in both directions. Here we're using tick marks to represent a number line, but you can think of those as points with values. Coplanar points are points that lie together on the same plane. So again, co means together, and planar means on the same plane, so together on the same plane. So let's draw a plane. I'll draw a horizontal plane. So here is my horizontal top and bottom, slightly offset. And inside this, let's put a bunch of points. I'll use point A, B, C, D again. And again, for contrast, I'll put a point outside the plane, call that point E. So E is not coplanar because it is outside the box. So I would say points A, B, C, and D are coplanar. As an example, well, think of pizza toppings. Alright, so the pizza is flat surface, there's your crust, and you have all kinds of toppings on the top of the pizza. They're all together on the same surface. They are coplanar points. Now, I need to add a couple of diagrams here in the bottom margin. We need this for some of our homework problems, and I just didn't have something set up ahead of time. So we'll just use this to practice sketching. There are two examples that we want to consider here. So we're going to take a look at how do we sketch a line in a plane. I'll show you how to do that. And then secondly, how do we sketch a line passing through a plane? There are certain techniques that we got to use to communicate that visually. Alright, so let's start off with this first one. how do we sketch a line in a plane? Well, let's start off with the plane. I'll draw a horizontal plane. So again, create horizontal top and bottom sides, slightly offset, close the left and right hand side. Now it's a plane, so we have to name it. So give it a capital letter in the corner, no dot because it's not a point, it's a plane. Now let's create a line that is inside the plane. So that means it has to be fit inside this little box shape. So here's my line. You need arrows on both ends. Now because that's a line, we have to name it. And so we have a variety of ways of naming it. We could name it by 2 capital letters represented by points on the line, or we could use a single lowercase italicized letter. It's really your choice. I'll use the 2 points. So I'll call this line AB. So this is line AB in plane M. But how would we draw it if that line were to be passing through the plane? All right, well again, let's start off by drawing the plane. Again, I'll draw a horizontal plane. Call that plane M. Now, if we want the line to pass through the plane, that means it has to puncture the surface and go out the bottom side. So to do that, we're going to pick a point. This is the point where the line will pass through the plane. So some of the line will look like it's on top of the plane, and then some of the line will look below it. And I'm going to angle the line a little bit. I'm going to draw it at an angle like this so it just fits in my paper margin a little bit. So here is the line. Again, the line has to have an arrow on both sides. At this point it just looks like a ray. But this is the top part of the line above the plane, and right there, that's the point where it is puncturing through the surface of the plane, and then the line has to come out the bottom edge. But it's hidden by the surface of the plane. So we have to draw these dashed lines to indicate that it's there, but you just can't see it because it's behind, and then beyond the edge, we then return to a solid line. And there's your other arrow. So we need to create a name for this point where the line punctured the surface of the plane. And then because we're naming the line, we need one other point, and it doesn't matter where it goes. It could be below or above. So I'll just put it above the surface of the plane and call that B. So we would say line AB, or line BA, passes through plane M at point A. So those are the basics. Now we have a few problems on the next page to help practice our notation and the vocabulary. And this is what you'll see on your homework if you try that as well. So take a look at these diagrams. We'll go through each of these, and we'll see if we can identify each of these different notations. All right, here's an overview of the shape we're looking at. Here's my horizontal plane. I see a capital letter in the corner, and that looks like plane Z. I see a line that is in the plane, and then I see a line that is passing through the plane. You can see where this line has turned to some dashes right there. That's how we know this line is going right through the surface of the plane, puncturing the surface at point M. We have some points on each of the lines. We have some lowercase letters at the ends of each line. And then also we have this point P, which is not on the line, it's just floating somewhere within the plane itself. So the first thing we're looking at doing is to give another name for plane Z. Now if you forget how to do that, you go back to your vocabulary page, look for planes, look to see how we named planes. So we can name a plane with 3 letters, but you have to be careful. It's not any 3 letters, it's through any 3 points not on the same line. So if I'm looking at this plane, here we have a line with 3 letters, L, M, N, but I cannot use those 3 because they are on the same line. I have to use 3 letters not on the same line, like L, M, and P. So that would be a good name for this plane. Now it just asks for one, but I'm going to give a few more examples just so that we can see what we're doing here. I could use letters M, N, and P as well. That would be 3 letters not on the same line. Here's what not to do. Do not use L, M, Z, because Z is not a point. It has to be 3 points on the plane, and Z is not a point. And again, don't use the 3 letters that are in a straight line. So one more combination, we could use letters L, P, and N. L, P, N. And again, those letters can be written in any order. You can shuffle them around. Part B, name 3 points that are collinear. So again, if you forget what collinear is, you go back, take a look at your vocabulary page. Collinear are points that lie on the same line. And there's our example of collinear points. Notice when we list these points, we have to separate them by commas so it does not look like the name of a plane. So 3 points that are collinear, points L, M, N. Notice this little b, that's not a point. That's the name of a line because it's a lowercase italicized letter. So, points L, M, N. L, M, N is what we want. We don't want P because it's not on the line. L, M, N. You have to separate them by commas so we know they're individual points. When you're naming the plane, you don't separate those letters by commas. All 3 letters go together to name the plane. Part C, name 4 points that are coplanar. All right, coplanar points are points that are on the same plane. So here's some points inside the plane. We have L, we have M, we have N, we have P. But again, Z is not a point. There's no dot next to that letter. So we would have points L, comma, N, comma, P. Give 2 other names for, now we look at that symbol and we name it. That's a line symbol with the arrows on both sides. So line, L, N. So we want 2 other names for this line. Let's find the letters L and N. So L is on the left side of the line, N is on the right side. But we could use M, that works. So how about line M, N? So put the line symbol above it, and capital letters M, N. Again, you can do it forwards or backwards. We could use L and M. So line, L, M. Again, forwards or backwards. You could even take the given name and just shuffle those letters around and rewrite that backwards. Now it just asks for 2, but let me give you one more. You could also call it line B. Right? You can use that lowercase italicized letter that's off to the side of the line as the name, as long as you put the word line in front of that letter. Alright, here's the last one in this example. Name a point that is not coplanar with L, N, and P. Not coplanar. So that means these points are on the same plane. We want to think of a point that is not on the same plane. Alright, so here we're finding points L, N, and P. So there's L, N, and P. All of them are inside this horizontal plane. So the only one that's not is point Q. That's clearly above the plane, and that's our answer. Let's take a look at example 2. Example 2, it looks like a simple diagram with just a pair of lines crossing, but this is one of the trickiest problems you'll encounter because we're talking not just about the lines, but about rays. And I find students have a lot of trouble remembering how to name and identify the correct ray. Well, in part A, we're starting off with a segment. Give another name for segment Vx. Notice there's no arrows on that bar, so it's not a line Vx, it's a segment Vx. What is a segment? Well, a segment is part of a line. We don't have the arrows on either side, right? We just name it using those endpoints. So let's find the letters V and X on the diagram. There's V, there's X. that segment. Now you notice that this does have the arrow, so there is a much bigger line, but if you were to chop off those arrows and just look at the piece that goes from V to X, that's the segment we're talking about right between there. So we can name that forwards or backwards. So another name for segment VX would be segment XV. Part B, name all rays with endpoint W. Now remember, we said that when naming rays, the endpoint is always listed first. We're starting at that letter and moving in a certain direction. So that means if we are starting off with endpoint W, that means W has to be listed first. So let's start at W and go up. So this would be ray WY. Let's start at W and go down. So this is ray WZ. Let's start at W and go to the right. So this is ray WX. And then start at W and go left. This is ray WV. Now notice what's happening here. Even though we're looking at this ray, which is pointing leftward, the arrow still points to the right in its notation. We always read from left to right, so our letters go from left to right, and the arrow points left to right. Notice in every case, the endpoint is always listed first. That's what we're seeing here. There's a follow-up part to this question, and that says, which of these rays are the opposite rays? Okay. Opposite rays would be two rays that point in the opposite direction. So the ray going up, the ray going down, that's a pair of opposite rays. So I would say ray WY and ray WZ are opposite rays. And then in the same way we have the rays going to the right and to the left. So we have ray WX and ray WV are opposite rays. All right, what do you think about this? In part C, it's asking you a question. Are ray VX and ray XV the same ray? Now let's back up just a moment. Remember, when we were naming lines, there were lots of ways to name lines because we could shuffle the letters in either order, line AB or line BA. Same with naming segments. We could shuffle the letters around in either order. But when you got to a ray, you could not shuffle the letters around because the endpoint had to be first. There was only one way to name that. So keep that in mind as we answer this question. Let's find these on the diagram. Ray VX and ray XV. So you can see the letters are shuffled around. That would communicate that the two endpoints are different. This says start at V and go through direction X. So here we're starting at V, going to the right, and that would extend forever to the right. The second ray named is ray XV. That says start at X and go in the direction of V. That would extend to the left. Well, they don't have the same endpoint. They're not pointing in the same direction either. So that answer is no. They are not the same ray. What do you think about this next question? Are ray VW and ray VX the same ray? Notice they have the same letter, so they do have the same endpoint. That's good, but we also have to check, are they extending in the same direction? So ray VW says start here at V and extend past W, so that would go to the right. The second name says start at V and go in the direction of X, which is also to the right. So this answer is yes. So how do we know? There are two things you are looking at. They have the same endpoint, and the second item we're looking at is, do the rays travel in the same direction? They travel in the same direction. They have the same endpoint, and they travel in the same direction. Here in example 3, you can see now we have not two lines, but two planes. We have this shaded plane, and then passing through it is another plane. So think of this maybe as being like a floor, if you will, and I know this is slanted, but think of that as being the wall. And so where the floor touches the wall, you have this crease right there. That would be the crease in the corner where the floor meets the wall. So let's identify some of these features. Name the intersection of line MX and line A. We're looking at two lines here. So line MX. There's M. Below that is X. So this is line MX, sort of going up and down, if you will. And then the second line is called line A. And there's little lowercase a that's describing this line that's extending left to right. So the first line is going kind of up and down. The second line is going like this. You can see where they form the cross. That's where they meet. That is the point called M. So the intersection is where the two lines meet. They meet at point M. And lastly, name the intersection of plane C and plane D. All right, so plane C, here's the capital C in the corner of this plane, and there's plane D. Little d, letter D is in the corner of that plane. And so we're looking to see, where does this floor touch this wall? Well, it touches at this crease, which is not a point, but a whole line. So we have to name this line. Let's call that, there's only one capital letter, so I have to use the lowercase a. This is line A. And there's your examples. Try the homework problems, and you'll want to take a close look at those problems involving the rays especially. Those ones tend to be the trickiest.